What's up guys, welcome back to another video. So this video is going to be pretty technical and computer science and software engineer related. So I'm going to be talking about hottest tech stacks, and I'm going to be comparing two positions. One is really recently emerging position called a DevOps, and other one called a traditional software engineer. I'm going to be comparing tech stacks and two positions. There are more positions than DevOps and software engineer. There would be another one like QA or software developers or a programmer or project manager or product owner. There are a lot of positions in computer science industry, like tech industry, but mainly when we talk about engineer, computer science and software engineer, we're going to be talking about software developer, QA analyst. QA stands for quality assurance, or generic software engineer, and emerging one is DevOps. And DevOps is really not quite just a replacement, but the new field and position evolved from, let's say, traditional sysadmin or like network or database, Linux. This one is being evolved to DevOps, and when we talk about DevOps, it's really about cloud and DevOps, because infrastructure before was here, and this stuff was on-premise, meaning that traditional companies had maintained their own infrastructures, like hardware, network, database, servers. But right now, it's being replaced by elastic cloud platforms like AWS, Azure, Google Cloud Platform, like Kubernetes, OpenShift. So these days, almost all the tech companies who require a lot of scalability, availability, they move on from on-premise to off-premise, which is usually cloud. And DevOps is dealing with this spectrum CICD pipeline, usually CICD. And then CI stands for continuous integration, and the CD stands for continuous deployment. And where does software engineer fit into this whole software development lifecycle? Let's say software development lifecycle, right? So this is from like requirement to designing to implementation to testing and maintenance. This is a whole lifecycle, which entail project manager and a product owner to talk with the customers and come up with requirements, and software architect does software designing, architectural design, and a software engineer, a software developer usually develop and implement code, and then QAs test. And after that, network, database, Linux, traditional sysadmin were responsible for deploying the stuff product or source code being deployed on actual production environment. So see a lot of stuff, let's say PO, PM, product owner, and project manager get involved in requirement gathering. And after that, let's say architect does designing, requirement, and then software developer does implementation, writing code, and then after that QA does test, right? And then after QA does test, what's going to happen is that if there's a go sign for a source code, let's say .jar file, then it's going to be passed on to these guys deployment. So Linux like network database admin to actually deploy. And then maintenance, kind of like site reliability engineer, which makes sure who makes sure that actual servers and all the infrastructures are running and up without downtime. So this is a whole flow, software development lifecycle: requirement, designing, implementation, testing, and deployment maintenance. And then you find a bug and then go back here and then actually refactor, and then it's kind of like a cycle. So software development is really a continuous cycle. And this is a CICD pipeline where continuous integration here happens. Like here is like a GitHub. And then test is like regression test, unit test. And then auto build, so like here, Gradle for auto build. And then auto test, basically regression testing done. And after that, what's going to happen is that once build up a source code or product executable file is successful, then it gets passed on to these different guys traditionally. But now DevOps handles everything. Kind of DevOps is the mediator between software developer and these deployment guys, like operation guys. Like that's why it's called dev. Dev part is here, and the operation part is here. Ops stands for operation. DevOps is really binding these two silos, and then now infrastructure is replaced by cloud. So now it's like infrastructure as code, Terraform, or AWS cloud formation template, which is kind of like a Terraform, infrastructure as a code. And then now here, there's a emerging technology called containerization. Docker is a pretty famous one. Basically, when you implement some source code like a jar, you usually use external third-party libraries and packages. So we bundle them up in container image, Docker image, let's say. And Docker image is really like an operating system image, but it's much lighter and smaller, and it's really portable. So you can just run this Docker image on local environment and then test it pretty easily, as opposed to having to set up all the infrastructure. So it's really portable and autonomous now. So Docker is being passed on from here to deployment here. Like here, we use Docker image here, and then after that deploy using different technologies like Kubernetes, AWS Elastic Container Service, or OpenShift to orchestrate multiple containers, make sure that all the containers are running. They can be ephemeral, meaning that one container can go down. So these guys are basically a centralized brain system to manage which one is up and running, which one is down. If it's down, then spin up another image. So that's that. This is another technology for DevOps. Kubernetes, it's called in general, umbrella term, it's called orchestration tool. Kubernetes, Elastic Container Service, and OpenShift, another one called Cloud Foundry, OpenStack, and then maintenance. It is about kind of also like release strategy, blue-green. Or canary release. But blue-green is pretty easy because this guy takes care of having sets of containers running, and it's easy to spin up new containers in cloud environment. So this now recap the technology for DevOps. A lot of technologies, Docker here, right? And then Kubernetes, OpenShift. What else? Configuration management stuff is like Ansible and stuff. Basically, we want to configure some running environment by injecting environment variable or parameter arguments, and then that can be done through like configuration tool like Ansible or Vagrant. Terraform is one for setting up infrastructure as a code. So before it wasn't really codified, but now it's codified. Everything's like reproducible with code. So that's that, a lot of stuff. And then here is like CICD pipeline. You usually build a script to automate running tests or like build script. So like Bash, Python for automation. Right. And then Docker is for containerization, like microservice architecture. Whereas here, traditional software developer, like software development, focuses on here. This is where the traditional one, and this was Agile. But Agile didn't really focus on like streamlining deployment strategy or like automation pipeline. It wasn't smooth. There was like silo between here, there was quite a bit of a boundary between here. So like once dev finishes his work or her work, it's like they're up to them, operation guys to deploy, but it takes like a few weeks or few months, because sometimes the code is really big, monolithic application wise. It takes so much time to like set up a right infrastructure, and configuration takes time. But now it's trying to break down this silo. So software engineer have like requirement, implementation, testing is also part of a software engineer job, documentation. Also, a software engineer can implement a lot of stuff like network level or application level or database level, middleware, a lot of different layers, implementation wise. And then there's also language wise, for example, Java, Python, or like front end, back end, server side scripting like Node. Front end like React is pretty popular now. Node is back end, server side. Python is pretty simple. Java is traditional. Banking like traditional legacy code really depends a lot on Java. But these website stuff like Node and React is pretty popular. Python, Java, C++ is really for like network layer or like operating system, because this is like a performance critical one, needs to be done with efficient one like memory management, so like network, routing, router. So so a lot of stuff, but software engineer, traditional one like software developer have been focusing on this just part, generally speaking. And ops guy were more like a system engineer. What does a system engineer mean? It's more like Linux, Unix, low level stuff, and then shell. That's called a system, like Linux, Unix system. That's why it's called a system engineer, right? So that's that. So there was really quite a bit of a distinction between, separation between software engineer and the system engineer, devs and ops before. And DevOps is really like tying them together, bring them as a one team. So DevOps deal with not only like DevOps really don't really develop a software like product per se, like using Java, Python, but however DevOps deal with like automation part, like CICD pipeline, to make sure it flows in the pipeline so that we can deliver product faster. So this comes back to the point of 3 V's. Volume, velocity, variety. So to achieve volume, which is like exploding these days because of scalability, right? And velocity, which is speed. Before, in a monolithic application, it took like a few weeks, even months, to deploy new version because it takes so much time to set up, virtual machine infrastructures. And once something goes wrong, then they need to go back and then fix stuff, and then it takes so much time. And then variety is, supporting multiple platforms or different programming languages. It's accepting a lot of different applications, like being more diverse and versatile. So to achieve this, like we have huge amount of traffic going to YouTube or Amazon, right? Let's say amount of data we are handling these days like exponential. Like amount of videos uploaded on YouTube, like more than terabyte, right? Same thing, Facebook, videos, search engine. The data is expanding. And then also we need to increase velocity to do business better, to deliver products to customers faster. For example, like Facebook example, they want to deliver products or new features to customers faster as opposed to previous traditional software development like strategy, like waterfall, which takes like 1 year to deliver. Like operating system wise, like a Microsoft or like Apple, they release operating system like every half a year, like a new version like every half a year or quarter, or usually like annual one. We want to increase the velocity, not necessarily just operating system, but just normal products and mobile apps, whatever that is. So to do that, we need to increase the speed here. And that's why like DevOps come in. So we need to automate, be able to make a software that is testable and deployable. So deployability, testability, automatability. So that's why we deal with a little bit of definitely system engineer, because we are dealing with infrastructure setup too. Like here's infrastructure. This part, we are dealing with infrastructure. And this part is really dealing with continuous integration of software products, like source code. We need to test, merge, build, and make sure there's no regression. And after that, we need to deal with networking, like routing, a lot of stuff like load balancer, proxy, IP tables, subnets, security, blah, 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 blah. To support scalable and available architecture, we need to design this kind of stuff, load balancer, availability, fail safe, how to design for failure, or how to design for scalability. We need to reproduce, like we need to replicate a lot of stuff like network, servers, load balancers, proxies, even subnets, network. We need to basically replicate a lot so that we have more availability. One maybe region is down, we need to have replication, right? So that is dealt by system engineer plus infrastructure like a cloud. So AWS, Azure, Google Computing Platform, Kubernetes, OpenShift. So a lot of new tech stacks coming up for DevOps, and that's why this is pretty hot. And in terms of demand, it's pretty high because previously it was like just maintaining one server or multiple servers and multiple databases. Right now with AWS and stuff, we can spin up AWS EC2 instances for pretty easy database as well. So we need to think a lot more than just one server, one network, one Linux server. We are thinking about volume now, which leads to a lot of stuff like this, architectural stuff. And then also infrastructure as code, automatability, autonomous. So yeah, I would say DevOps is really evolving and quite a bit of innovation happening. It's fun. Every single year it's new thing come out, like new technology come out. It's definitely emerging. And I would say right now, AI, data scientists, machine learning are pretty hot, but at the same time, DevOps are, in my opinion, as hot as this data scientist stuff, because DevOps is really in need now, in demand. Machine learning is more research oriented. DevOps is really like, you need to have like, real world experience to be DevOps, but you get paid more than typical software developer for sure. So yeah, that's my overview on hottest tech stacks. It is not just data scientist or machine learning or AI researcher. DevOps is really like this AWS, like Azure, Google Cloud, Kubernetes. So much fun for me. I need to read and learn every day is like a learning experience, and then everything like when I was a software developer before, I was like making Java and Android application before. I didn't need to deal with this. I didn't deal with the system engineering like Linux or like shell commands, bash scripting. I didn't know much about load balance. I didn't know anything about load balance before. I didn't know much about proxy. I didn't know anything about subnets or IP tables, firewalls, or like default gateway. I mean, we learned this in network course, but it was never like practical knowledge for me. So now, like doing DevOps, it's cool that I kind of needed to refresh my knowledge on like load balancing and stuff, and it's really not the research-oriented stuff. It's really the practical stuff. It was cool, and also I learned about Docker containerization, Bash and Python scripting. I got pretty good at Bash scripting, containerization, creating a new Docker, how to Dockerize everything to increase the velocity of development, testing, and deployment as well. Like release strategy wise, container is pretty easy to do that because it's maintained by this orchestration tool. So yeah, this is kind of like a brain dump. DevOps versus software engineer. DevOps is still subset of software engineer. So, software engineer is a superset of DevOps. So it's like this. Don't know if we have space. We don't. But really, if you take one thing out from this video, it is about the CICD pipeline, like continuous integration and continuous deployment. This. If you take out only one thing, take away one thing from this video, it's this. Because traditional software development, software engineer, will only focusing on this part. Agile only focus on this one. What's DevOps, which is a new kind of a methodology and a culture, is about bringing everything, entire process together as one continuous pipeline. And this does make a lot of sense. This does require much broader computer science knowledge. You need to be versatile, both on the side of dev and ops, system and the software. You need to understand like not only data structure or algorithm, but also networking, operating system, scalability, like cloud computing, which is really about infrastructure, and also availability, new stuff like 3Vs. Also, there's a consistency, availability, and partition tolerance, CAP theorem. This is what you're going to learn in cloud computing course at the fourth year course in computer science university. CAP theorem, basically, you can only have two of the three. You can't have everything. consistency meaning data consistency, availability meaning that it's available, partition patterns meaning that even if one zone region is down, the website should be still up and running, stuff like that. Anyways, that's that. If you have a few questions about this in AWS, or if you have questions about, let's say, Kubernetes, or what is system engineering, or what is QA, what is unit test, what is Gradle auto build, what is container, microservice, Docker, let me know in the comment section. I'll make another follow-up video based on your questions and comments. And if you want me to create another kind of video, different kind of or relevant topics, do let me know as well. I want to make more videos about what I'm doing, what I've been learning about. I want to share my knowledge and experience because this is really emerging field past 2-3 years really, and it's really fun. So I want to share with you guys kind of stuff that I'm learning in real world and being a cloud DevOps engineer. So yeah, it's fun. Let me know. So I'll talk to you guys in next video, right? Bye bye.